CIET NCERT presents audiobook Curiosity, Textbook of Science for Grade 7.
Page number 153, Chapter number 11, Light, Shadows and Reflections. On the right hand side of this page, a QR code is given, on scanning to which you can get access to the other resources related to this chapter. In the Western Ghat region of Maharashtra, Keshav spends part of his summer vacation at his friend Jatin's grandparents' village. Having lived in a big city, he finds the forests, fresh air, sounds of gushing streams, and chirping birds a novel experience. However, for Keshav, the most fascinating sight is the dance of hundreds of fireflies at night, flashing their lights in a wonderful performance. Jatin's grandparents explain that fireflies are seasonal insects and they use light to communicate. Unfortunately, Keshav also learns the number of fireflies is decreasing due to light pollution, reduced forest cover, and excessive tourism. At the end of their vacation, Keshav and Jatin board an evening bus back to their city. As the bus winds through the hilly roads, Keshav watches the moonlit landscape and the beams from the headlights of passing vehicles flashing by. He is reminded of the many poems and songs about moonlight and wonders. Does the moon actually produce its own light? Did we not learn in the chapter Beyond Earth in the grade 6 science textbook Curiosity that all other objects in our solar system shine only by reflecting the light of the sun? Is moonlight just reflected sunlight? Which objects give off their own light? While thinking, he notices something strange. Light seems to move in a straight line. Children, at the bottom of this page, a picture of a peaceful village is given. Sky is filled with twinkling stars. In the background, hills run across the picture. Buses and trucks driving slowly over the hilly roads. A large tree stands in the center. Bushes, plants, a house, a stream of water are there. There are several fireflies glowing brightly with their natural bright light. This picture represents that stars and fireflies are natural sources of light. Page number 154. 11.1. Sources of light. The sun gives out or emits its own light and is the main source of natural light on the earth. Stars, lightning, natural fire, and certain animals also emit their own light, as given in Figure 11.1. Figure 11.1 is given on the left-hand side of this section, representing 4 pictures of natural sources of light like sun, stars, lightning, and Jugnu. In ancient times, humans learned to create fire, the earliest form of artificial lighting. With time, they learned to create fire using different fuels such as animal fat, oil, wax, and gas, as given in Figure 11.2. On the right-hand side of this section, Figure 11.2 is given. Fire as a source of artificial light representing 5 different sources of light. First, a torch made of wood held in a hand with orange big flame. Second, a white wax candle stands with a burning flame at top. Third, a diya or earthen lamp with a cotton wick is lit and glowing. Fourth, a hurricane lamp with glass cover on metallic frame with a flame inside. Fifth, an oil lantern which is an older device. These pictures are given in this figure. With the invention of electricity and different kinds of electric light sources, most of the lighting needs of humans are now met by electric lighting as given in 11.3. Figure 11.3 is given in the bottom of this section, which includes some sources of electric light like an electric arc lamp, a small tube-like torch bulb, a regular incandescent bulb, a long fluorescent tube light, a CFL bulb, and a LED bulb. Objects that emit their own light are called luminous objects. Objects that do not emit their own light are called non-luminous objects. The moon is a non-luminous object. It does not emit its own light. It just reflects the light emitted by the sun that falls on it. Children, at the bottom of this page, an interesting box is given titled as Science and Society. This box links with real-life applications showing how science has contributed to societal development. This box reads, Light-emitting diode LED lamps are modern light sources that consume much less power, are brighter, and last longer than traditional lamps. This not only reduces electricity bills but is also better for environment. Recognizing their advantages, the Indian government has made substantial efforts to promote the use of LED lamps nationwide. At their end of life, LED lamps must be appropriately disposed or recycled and not thrown in the garbage. Children, a picture of LED is provided inside this box. There is a picture of a boy which is given near this box who is doing a chemical activity and recording his observations. Page number 155, 11.2. Does light travel in a straight line? Let us do an activity to try to find out. Activity 11.1. Let us investigate. Step number 1. Take 3 matchboxes and make a hole in the inner tray of each matchbox, exactly at the same position. Step 2. Arrange these 3 matchboxes in a straight line. Make sure that all 3 holes are exactly at the same height and are in a line, as given in figure 11.4. Figure 11.4 Matchbox activity Light through holes. Demonstration of activity 11.1 is given in figure 11.4, which is provided at the right hand side of this section. Step number 3. Place a torch light on one side of the matchboxes, ensuring that its lamp is at the height of the holes. Step number 4. Place a cardboard or a screen on the other side of the matchboxes and obtain a bright spot on it. You may need to slightly adjust the heights of boxes. Step number 5. Move on of the matchboxes slightly to a side or up and down. Are you able to obtain the light spot on the screen now? When all the 3 holes are not in the same line, we could not obtain the light spot on the screen. These observations suggest that light travels in a straight line. There is a conversation between 2 children which is provided here. The girl asks, "Can we somehow check it in some other way?" Then the boy adds, "I have an idea. Let us try to see the candle flame through a bent pipe." Should we also try out this idea? Activity 11.2. Let us explore. There is a caution message. Use a lighted candle under adult supervision only. Step number 1. Take a long hollow pipe of some flexible material and align it so that you can see the candle flame as given in figure 11.5a. Step number 2. Now bend the pipe and try to see the candle flame again as given in figure 11.5b. Can you still see it? You could see the candle flame through a straight pipe but not through a bent pipe. This shows that light travels in a straight line. Figure 11.5 is given at the right hand side of this section, viewing candle flame through A. a straight pipe, B. a bent pipe. A girl is watching candle flame through a straight pipe and a bent pipe in this figure. Page number 156. At the top of this page, one more interesting box is given, titled as Dive Deeper. This box reads, Caution: use a laser only under teacher's supervision. Avoid using high-power lasers for this activity. A low-power laser pointer is sufficient. Never point the laser beam directly at anyone's eyes, as it can cause serious eyes damage. Pass a laser beam through a beaker filled with water in which a drop of milk is added to make the laser beam easily visible. What do you observe? Do you see that the beam of the laser light inside water follows a straight path? However, light can sometimes even bend around corners. This is something you will learn in the higher grades. Children, inside this box a picture of demonstrating this activity of passing a laser beam through a water glass is given. 11.3. Light through transparent, translucent and opaque materials. A dialog box is given. A girl is asking, what happens when an object comes in the path of light? Let us place objects made of different materials in the path of light and find out. Activity 11.3. Let us experiment. Step number 1. Collect objects made of different materials. Also, you will need a torch. Table 11.1. Light through different materials. This table includes 3 major columns. Column 1, material. Column 2, transparent or translucent or opaque. Column number 3, light will pass fully or partially or not at all. Column number 3 is subdivided into 2 more columns, my prediction and my observation. Column number 1 lists materials as cardboard, paper, glass, tracing paper, thick cloth, and 2 blanks are given for the students. For column number 2 and 3, blank spaces are given for the students to record their observations. Page number 157. Step number 2. List the material of the objects in table 11.1 and classify them into transparent, translucent and opaque. In the chapter Materials Around Us in the grade 6 science textbook Curiosity, you learn to classify materials into transparent, translucent and opaque depending on how you could see through them. Step number 3. Go to a dark room, turn on the torch and place it at such a position that you get a spot of light from the torch on a wall. Or you may place a cardboard screen as given in figure 11.6 and get the spot of light on it. Figure 11.6 is provided at the right hand side, which is indicating passing light through different materials. Where a football is placed between a torch and a cardboard, we can see the shadow of the football on the cardboard. Step number 4. We will now conduct this activity in 2 parts: prediction and observation. Predict. What will happen if you hold an object in front of the light coming out of the torch? Would you continue to see the spot of light on the screen? Note your prediction in table 11.1. Now, actually place the object between the torch and the screen. Does light pass through the object? Note your observation in table 11.1. Step number 5. Repeat this for all the objects. Was your observation the same as your prediction? What conclusions could you draw? Light passes almost completely through transparent materials. Light passes partially through translucent materials. Light does not pass through opaque materials. A dialog box is given. A boy is asking, what happens when an opaque object blocks the path of light? 11.4. Shadow formation. What do you see on the screen in activity 11.3 when an opaque object was placed in the path of light? Did you see a dark patch on the wall? Why was this dark patch formed? We now know that light travels in a straight line. So, when an opaque object is placed in its path, light is blocked. The dark patch where light does not reach is the shadow. Figure 11.7 is given on the right hand side of this page, which is indicating shadows around us. There are 2 pictures. In the first picture, a girl is making her own shadow in the park. And in the second picture, 3 children are making their shadows on a wall. Page number 158. We have noticed shadows of ourselves and other objects around us when we are in the sun or under a light, which is given in figure 11.7. Also, you might have had fun making different shapes with shadows sometime. Do translucent and transparent objects create shadows or not? Did you notice that in activity 11.3, opaque objects form darker shadows? Translucent objects make lighter shadows. Even some transparent objects can create faint shadows. Let us learn more about shadows. Activity 11.4. Let us explore. Step number 1. Collect some opaque objects of different shapes and sizes. Step number 2. Repeat activity 11.3, but this time carry out the actions mentioned in the first column of table 11.2. Step number 3. Observe the shape and size of the shadow on the screen for each of the actions. Did the shadow form in all cases? Was the shape and size of the shadow the same as the object? Step number 4. Record your observations in the second column of table 11.2. At the middle of this page, table 11.2 is given. Observation of shadows. Children, this table includes 2 major columns. Column number 1, action. Column number 2, observations regarding shadow. Column number 1 includes: first, the screen is removed. Second, the object is removed. Third, the torch is switched off. Fourth, the object is moved closer to the screen, keeping the torch and the screen fixed. Fifth, the object is moved closer to the torch, keeping the torch and the screen fixed. Sixth, the object is tilted, keeping the torch and the screen fixed. Seventh, the color of the object is changed. In the second column, students may record their observations regarding shadow. Blank spaces are provided. What conclusions do you draw from this activity? What do we need to observe a shadow? Does the color of the shadow change when the color of the object is changed? Shadows are formed when an object blocks light from falling on a screen. We need a source of light, an opaque object, and a screen to observe a shadow. The walls, floor, ground, or any other surface acts as a screen for observing shadows in our daily life. Page number 159. The shape, size, and sharpness of the shadow depend on the position of the object relative to the light source and the screen. The shadows may give information about the object, or we may not be able to guess the object at all. Changing the color of opaque objects does not change the color of the shadows. At the middle of this page, children, let's go through an interesting box named as Fascinating Facts. It highlights fun facts, interesting observations, and curiosity-driven questions. This box reads, Shadow play or a shadow puppetry has been a part of our cultural heritage for centuries. In this art form, flat, cut-out figures called shadow puppets are placed between a light source and a screen. By moving the puppets and the light, puppeteers can create lifelike movements, bringing the characters to life. Different regions have their own unique styles, like Charma Bahuli Natya in Maharashtra, Kilu Bome, and Tholu Bomalata of Andhra Pradesh, Togalu Gombeyata in Karnataka, Ravan Chaya in Orissa, Tholu Pavu Kotu in Kerala, and Bomalatam in Tamil Nadu. These are used not only for entertainment but also communicate important messages to the community. Children, a picture of a traditional shadow puppetry from Ramayana is also given inside this box. 11.5 Reflection of Light. Here is a conversation box. A boy is saying. In this section, a dialogue box is given where a boy is saying, When the opaque object was a shiny object like a polished steel plate, I got a shadow on the screen. But I also saw that there was a bright spot of light on the wall of the opposite side. Why was it so? Activity 11.5. Let us investigate. Step number 1. Find a shiny flat steel plate or a plain mirror, that is, a mirror that is flat and not curved. Step number 2. Take it outside and let the sunlight fall on the shiny surface. What can you do to redirect light on the wall on which the sunlight is not falling directly? Page number 160. Step number 3. Turn the shiny plate or mirror in different directions to redirect the light onto a wall or a nearby surface, as given in Figure 11.8. Figure 11.8 is provided at the left-hand side of this page, in which using mirror to redirect sunlight on a wall is demonstrated by a girl. Do you see a spot of light on the wall? Does it mean that the shiny plate or mirror has changed the direction of light? Step number 4. Now, tilt the shiny plate or mirror in different ways and observe the light spot on the wall. Does it change position? Notice how light always travels in straight lines and changes direction when it falls on the shiny plate or mirror. What conclusion do you draw from your observations? This activity suggests that a shiny surface or a mirror changes the direction of light that falls upon it. This change in direction of light by a mirror is called the reflection of light. Let us try to understand the reflection of light by a mirror. Activity 11.6. Let us experiment. Step number 1. Take a plain mirror with stand, a torch, a comb, a sheet of white paper and a strip of black paper. Step number 2. Using the black paper, close all openings of the comb except for one to make a thin slit. Step number 3. Spread a white paper on a table, hold the comb perpendicular to the sheet of paper and shine the torch light on the slit. Adjust the comb and torch slightly till you see a thin beam of light along the paper which has passed through the slit, which is given in figure 11.9a. Step number 4. Now, place the mirror in the path of the light beam while keeping the comb steady, as given in figure 11.9b. What do you observe? The path of the light beam is changed after falling on the mirror. The reflection of light occurs at the mirror. There is a dialog box where a girl is asking, "In a mirror, I can also see my face. Is that also due to the reflection of light?" At the left-hand side of this section, the setup of this activity is demonstrated in figure 11.9. A. A light beam. B. Reflection of light in a plane mirror. Page number 161. 11.6. Images formed in a plane mirror. Look into the mirror. Do you see your face in it? What do you see is a reflection of your face in the mirror. We also see reflections of other objects that are in front of the mirror. Let us try to find out more about this. Activity 11.7. Let us experiment. Step number 1. Take a plane mirror and a pen or some other object. Step number 2. Place the pen in front of the mirror as given in figure 11.10. Figure 11.10 is given on the right hand side of this section, which is indicating image of a pen in a plane mirror. What do you see in the mirror? It appears as if a similar pen is placed behind the mirror. The pen which appears behind the mirror is the image of the pen formed by the mirror. The pen itself is the object. Step number 3. Now, move the pen to different positions in front of the mirror and compare the sizes of the images of the pen at each position. Are the two sizes the same? The image formed by a plane mirror is of the same size of the object. Step number 4. Again, move the pen to different positions in front of the mirror and observe if the image is upright at each position. Does the tip of the pen appear on top at each position? An upright image is called erect. An image formed by a plane mirror is erect. Step number 5. Now, place a screen vertically behind the mirror. Move it around. Do you get the image on the screen? Repeat this by placing the screen in front of the mirror. The image formed by a plane mirror cannot be obtained on a screen. Activity 11.8. Let us experiment. Step number 1. Stand in front of a plane mirror and look at your image as given in figure 11.11. Notice how far it appears to be from the mirror. Step number 2. Now stand close to the mirror. Is the image also closer to the mirror? Step number 3. Stand at different distances from the mirror and notice how far the image appears to be from the mirror in each case. Do you find any relation between your distance from the mirror and the distance of your image from the mirror. At the right hand side of this section, figure 11.11 is given. In figure 11.11, a boy is observing his own image in a mirror. Page number 162, you might have noticed that when you stand close to the plane mirror, the image also appears to be close to the mirror. The image appears to be far from the mirror when you stand far from the plane mirror. Raise your left arm. Which arm does your image raise? Touch your right ear. Which ear does your image touch? You find that your left appears right in your image and your right appears left in your image. This type of perceived left-right reversal is called lateral inversion. There is lateral inversion in the images formed by a plane mirror. There is a dialog box where a boy is surprised to realize that lateral inversion of the word ambulance is written on the ambulances. He is saying, "Oh, now I realize why the lateral inversion of the word ambulance is written on an ambulance. It reads ambulance when viewed from the rear view mirrors of the vehicle ahead of the ambulance." Children, at the middle of this page, an interesting box is given which is named as Fascinating Facts. This box tells us when mirrors were invented is not known. Earlier, mirrors were made by polishing stone or metal. When glass mirrors started being made, the art of making metal mirrors got lost gradually. However, it still survives. For example, in Kerala, where Arnamulla Kannadi, a unique metal surface mirror has been made for centuries. A picture of a mirror is also provided with this box. There is a dialog box where a girl is asking, "Can we see an image of an object only in a mirror, or are there some other ways as well?" 11.7 Pinhole Camera. A pinhole camera is a device in which the light rays from an object pass through a tiny hole or a pinhole and form an image on a screen. Page number 163, Activity 11.9. Let us explore. There is a caution message. Use a lighted candle under the adult supervision only. Step number 1. Take a piece of cardboard and a candle. Make a small hole in the cardboard. Step number 2. In a dimly lit room, position the cardboard at a short distance from a screen. Step number 3. Place a lighted candle in front of it as given in figure 11.12a. At the right hand side of this section, figure 11.12 is provided. Figure 11.12a, a simple pinhole camera is demonstrated. B. Image of a candle flame on the screen is demonstrated. What do you see on the screen? Light coming from the flame passes through the hole on the cardboard and forms an image of the candle flame on the screen. Do you notice anything surprising? The image of the candle flame is upside down, that is, inverted. Let us now make a pinhole camera which you can use outdoors. Activity 11.10. Let us construct. Step number 1. Take 2 boxes of cardboard such that one can slide into another with very little gap in between them. Cut open one side of each box. Step number 2. On the opposite face of the larger box, make a small hole in the middle as given in figure 11.13a. Step number 3. On the opposite face of the smaller box, cut out a square from the middle with a side of about 5 to 6 cm. Cover this opening with a thin translucent paper like a tracing paper to form a screen, which is given in figure 11.13b. Step number 4. Slide the smaller box inside the larger one in such a way that the side with the tracing paper is inside, as given in figure 11.13c. At the right hand side of this section, figure 11.13 is provided in 3 steps, where a sliding pinhole camera is demonstrated here. Hold the pinhole camera with the pinhole facing the object and look through the open side of the smaller box. Cover your head and the camera with a dark cloth. Look at a distant object like a tree or building in bright sunlight and move the smaller box forward or backward until an image appears on the tracing paper. Do the images seen in the camera show the colors of the objects on the other side? Are the images erect or upside down? Page number 164. At the top of this page, an interesting box is given which is titled as Dive Deeper. This box reads, a pinhole camera gives an upside down image. On the other hand, there is lateral inversion in the image formed by a mirror, but it is not upside down. We will learn more about this in higher grades. 11.8. Making some useful items. After having learnt that light travels in a straight line and is reflected by mirrors, it is time to create some useful items based on this learning. 11.8.1. Periscope. We can make a simple periscope by placing 2 plane mirrors in a Z-shaped box, as given in figure 11.14. Figure 11.14 is provided at the left-hand side of this section, where making and using a periscope is demonstrated. Reflection from 2 mirrors enables us to see objects that are not visible directly. Periscopes are used in submarines, tanks, or by soldiers to see outside their bunkers. You may use it to look ahead when standing behind taller friends. 11.8.2. Kaleidoscope. Get 3 rectangular plane mirror strips of equal width and join them together in a triangular manner as given in figure 11.15a. You may use 3 strips of thick reflective paper instead of mirrors. Fix these in a circular tube of thick chart paper as given in figure 11.15b. On one end of the tube, fix a transparent plastic sheet using a rubber band or an adhesive tape. Place several broken pieces of colored bangles or beads on this, figure 11.15c, and cover it with a tracing paper using a rubber band or an adhesive tape. When you peep through the open side, you view a beautiful pattern which is given in figure 11.15d. Even if you leave both sides of the kaleidoscope open and point it towards a tree or other objects, you see beautiful patterns. At the left-hand side of this section, figure 11.15 is demonstrating the making and usage of kaleidoscope. Page number 165. An interesting feature of the kaleidoscope is that one always gets to see a different pattern every time the kaleidoscope is turned about. Since there are 3 mirrors and multiple images, due to reflections of reflections, many interesting patterns are formed. Designers and artists often use kaleidoscopes to get ideas for new patterns. Children, the next section of this chapter is In a Nutshell. Before coming to this section, there is a picture on the right hand side where a cheerful girl is standing inside an open walnut shell. She is holding a paper with some notes written on it. This picture is symbolizing the idea of summarizing the chapter. Now, let us summarize this chapter into some points. Point number 1. Objects that emit their own light are called luminous objects. Point number 2. Light travels in a straight line. Point number 3. Light passes almost completely through transparent materials. Light passes partially through translucent materials. Light does not pass through opaque materials. Point number 4. A shadow is formed when light is blocked by an object. Opaque objects form darker shadows. Translucent objects make lighter shadows. Some transparent objects can create faint shadows. Point number 5. The change in the direction of light by a mirror is called reflection of light. Point number 6. The image formed by a plane mirror is of the same size. As the object is erect, cannot be obtained on a screen and is laterally inverted. Point number 7. A pinhole camera creates an inverted image of an object on a screen. Coming to the next section, let us enhance our learning. On the right hand side of this section, an illustration of a boy is given, who is encouraging us to participate in this section. The boy is sitting confidently on a block with a question mark. He is holding a word block which is named as inquiry. He is climbing through a rope and blocks. These blocks are shaped like big stones and has a question word written on each of it. Words are what if, why, when, where, what could, can it, question mark, which, how long, whose, what will happen, what should, what else, why not. Children, this picture reminds us to keep asking questions to learn better. Children, this picture reminds us to keep asking questions to learn better. Question number 1. Which of the following are luminous objects? Mars, Moon, Pole Star, Sun, Venus, Mirror. Question number 2. Match the items in column A with those in column B. Column A includes pinhole camera, opaque object, transparent object, shadow. Column B includes blocks light completely, the dark region formed behind the object, forms an inverted image, light passes almost completely through it. Page number 166, question number 3. Sahil, Rekha, Patrick and Kasima are trying to observe the candle flame through the pipe as given in figure 11.16. Who can see the flame? In figure 11.16, which is provided at the left-hand side of this question, there are Sahil, Rekha, Patrick and Kasima who are watching a candle flame through a branched pipe. Question number 4. Look at the images given in figure 11.17 and select the correct image showing the shadow formation of the boy. In figure 11.17, there are 4 images in which a child is observing his shadow from different directions. Question number 5. The shadow of a ball is formed on a wall by placing the ball in front of a fixed torch as given in figure 11.18. In scenario first, the ball is closer to the torch, while in scenario second, the ball is closer to the wall. Choose the most accurate representation of the shadows formed in both scenarios from the options provided A and B. At the left-hand side of this question, the scenarios are represented through pictures in figure 11.18. Question number 6. Based on figure 11.18, match the position of the torch in column A with the characteristics of the ball's shadow in column B. Now, there are two columns. Column A lists first, if the torch is close to the ball. Second, if the torch is far away. Third, if the ball is removed from the setup. Fourth, if two torches are present in the setup on the left side of the ball. Now, column B lists first, the shadow would be smaller. Second, the shadow would be larger. Third, two shadows would appear on the screen. Fourth, a bright spot would appear on the screen. Page number 167. Question number 7. Suppose you observe the tree which is given in figure 11.19 through a pinhole camera. Sketch the outline of the image of the tree formed in the pinhole camera. Figure 11.19 is provided with this question where a long tree is given. Question number 8. Write your name on a piece of paper and hold it in front of a plane mirror such that the paper is parallel to the mirror. Sketch the image. What difference do you notice? Explain the reason for the difference. Before coming to the next question, children, there is an illustration at the right-hand side of this page. In this illustration, a smiling girl is climbing up step by step through a rope ladder. Each step of a ladder represents a word like curiosity, exploration, inquiry, discovery, and innovation. The picture is indicating that all these steps lead to innovation. Question number 9. Measure the length of your shadow at 9 a.m., 12 p.m. and 4 p.m. with the help of your friend. Write down your observations. First, at which of the given times is your shadow the shortest? Second, why do you think this happens? Question number 10. On the basis of following statements, choose the correct option. Statement A. Image formed by a plane mirror is laterally inverted. Statement B. Images of alphabets T and O appear identical to themselves in a plane mirror. First, both statements are true. Second, both statements are false. Third, statement A is true, but statement B is false. Fourth, statement A is false, but statement B is true. Question number 11. Suppose you are given a tube of the shape which is given in figure 11.20 and two plane mirrors smaller than the diameter of the tube. Can this tube be used to make a periscope? If yes, mark where you will fix the plane mirrors. Figure 11.20 is provided with this question where a pipe in the shape of C letter is demonstrated. Question number 12. We do not see the shadow on the ground of a bird flying high in the sky. However, the shadow is seen on the ground when the bird swoops near the ground. Think and explain why it is so. Now, coming to the next section of this chapter, exploratory projects. First, have you ever seen a firefly where you live? If no, ask your elders if fireflies were seen earlier in your region. If yes, find out the reasons for their not being seen anymore. Develop a story about it. Second, repeat activity 11.4 but this time Cover the face of the torch with a colored transparent paper and observe the color of the shadow. Repeat this using transparent paper of different colors. Report your conclusions. Page number 168. Before coming to the next exploratory project, let us describe an illustration which is given on the left-hand side of this page. An interdisciplinary zigzag rope chart is provided here, which is depicting that all the areas like history, art, geography, society, technology, and economy are integrated. Now, coming to the next exploratory project. Third, a plane mirror forms only a single image of an object. But what will happen if two or more mirrors are kept at an angle with each other or parallel to each other? Find out by placing two mirrors as given in figure 11.21. Figure 11.21 is provided here, which is indicating observing images in two mirrors, where a bottle cap is placed in front of two mirrors which are joined adjacent. Fourth exploratory project. You are given a small piece of a plane mirror. Can this piece form an image of an object much larger than the mirror, like a large tree? Think and predict. Then carry out the activity. At the end of this chapter, there is an interesting box which is provided at the middle of this page, which is named as Fascinating Facts. Light emitted by the sun takes about 8 minutes and 20 seconds to reach the earth. Hence, if the sun were to suddenly stop emitting light, we would not know that for another 8 minutes 20 seconds. Chapter 11 ends here.
Curiosity. You were just listening to this audiobook, Textbook of Science for Grade 7. Narration: Harsh Priya. Sound recordist: Muhammad Faizan Khan. Production assistant: Surendra Kumar. Directed and produced by Vimalesh Chaudhary. This audiobook is brought to you by CIET NCERT, New Delhi, India.